All right, so this is section 1.4. The title is Lines, and this is my part 2. We are going to talk about how to graph lines given a point and the slope. And coincidentally, we're using the point-slope formula. All right, so we're going to draw a graph of a line that contains the point 3, 2 and has a slope of 3/4. It looks like this. If you plot 3, 2 on your graph, and then you go up 3 and over 4, you'll get to the point 75. That line continues on and on forever. A graph of a line that starts at the point 3, 2 and has a slope of -4/5. So you start at 3, 2 and you go down 4 over 5. And then that line represents slope and point. All right, so we're going to now do finding the equation of a vertical line. So if we're graphing x equals -2, you want to look at your graph and go, where is x equals -2? It's right here, and it's in fact right here, and it's here, and it's all along this vertical line here. So then you connect those dots. And anytime you have a vertical line, you'll have an x equals equation. So here's the equation of a vertical line. Make sure you write this down, definitely important, and also combine it with this picture. So x equals -2 means all of our values are at x equals -2. It's a straight line up and down, crosses at -2. All right, we're going to use the point-slope form of a line and identify horizontal lines. So we're switching our perspective. The point-slope form of an equation is our y, so this stays y minus whatever our coordinate is, y value in our coordinate, equals the slope times x minus whatever the x value is in your coordinate. For example, make sure you guys put this in your notes. So for example, if I have a slope of -3 and a point of -1, 4, I take my point slope form and I'm going to put in 4 for my y1, -1 for my x1, and -3 for my slope. Then I want to simplify that down. If you don't simplify, it's not going to give you out the correct answer when you take your quiz. And then to get it in slope-intercept form, you add the 4 to both sides to get y equals -3x plus 1. The graph of that looks like this. So if you were at -1, 4, the slope is down 3 over 1, and this equation represents that line. All right, so now let's think about horizontal line. Horizontal lines always have a slope of 0. And then you plug in -4 for the y2 and 2 for the, y1 and 2 for the x1. You get y plus 4 equals 0 or y equals -4. So that's a horizontal line that crosses the y-axis at -4. Make sure all this is in your notes. So the equation of a horizontal line is y equals b. Put this in your notes, where b is the y-intercept. All right, we're going to find the equation of a line when we have 2 points. So write this in your notes. Equation of a line containing points -1, 4, and 3, -1, and then we're going to graph that line. First thing you want to do is find the slope, y2 minus y1 over x2 minus x1. Simplify that. If it simplifies to a whole number, make sure you just include the whole number and not the over 1. And then we put this in point slope. So we pick our first point, and it doesn't matter which point you use. Either point is the correct answer. So we put 4 in for y1 and -1 in for x1. Simplify that. Negative and negative is a positive. And the graph of this looks like so. Writing the equation of a line in slope-intercept form. This is slope-intercept form. Make sure you put this in your notes. Y equals slope times x plus b, which is the y-intercept. So go ahead and graph all these equations in your graphing calculator. And let's see what happens. If you notice, all of our b's are the same and it's our slopes that change. So we've got our horizontal line here. We have our x plus 2 here, negative x plus 2, 3x plus 2, and negative 3x plus 2. We know that lines y equals mx plus 2 all have the same intercept. Now let's look at lines with all the same slope. Each of these lines has a slope of 2. And it's just their y-intercepts that change. So what can we conclude about lines that have the same slope? That's right, Jimmy. Lines with the same slope are all parallel. Okay, identify the slope and y-intercept of a line from its equation. So find the slope and the y-intercept of the equation 3x minus 2y equals 6 and graph the equation. We want to keep in mind y equals mx plus b. So we're going to solve for y. So we subtract 3x from both sides and divide by -2. -3 divided by -2 is positive 3/2, and 6 divided by -2 is -3. So comparing it to the slope-intercept equation, we know that our slope is 3/2 and our intercept is -3. And here's the graph of that equation. Last one. We're going to graph lines written in general form using intercepts. So the first thing we need to do is know that general form is ax plus by equals c, where a, b, and c are real numbers, and a and b are not both 0. So we're going to graph this guy by finding its intercept. So the cool thing about general form is that it makes it really easy to find intercepts. Because if we put in 0 for y to find the x-intercept, you get 3x equals 6 or x equals 2. So 2, 0 is the x-intercept. Then we plug in 0 for x to find the y-intercept, and we get 2y equals 6. Divide by 2, and we get y equals 3, so the y-intercept is 0, 3. And the graph looks like this. So you plot your intercepts, draw a line through them, and you have your graph. All right, equations of parallel lines. Parallel lines have the same slope. different y-intercepts. Okay. If two non-vertical lines are parallel, then their slopes are equal, and they have different y-intercepts. If two non-vertical lines have equal slopes, then they have different y-intercepts, and they are parallel. All right, so we have these two lines. We're going to show that they are parallel. Well, if we convert to the slope-intercept form, so we add 3x to both sides, divide by 2, we can see that the slope is 3/2. If we can show that this guy's slope is 3/2 and it has a different y-intercept, then we can say that they're parallel. So we're going to subtract 6x from both sides, divide by 4 and simplify, and we see that our slope is 3/2, so that's the same, and our intercept is 0. So because they have the same slope and different y-intercept, they are parallel. All right, so this is how we'll usually see this information. Given a point on a line that we know is parallel to another line, find the equation of that line. So the first thing we're going to do is solve for y, so we can find the slope. When we do that, we get 3/4 x minus 3, so the slope is 3/4. So the slope of our equation for the line we care about is going to be 3/4. It's going to go right here. We're going to plug in the point. 3 is going to go in for y1, and -1 is going to go in for x1. We simplify that down, and in slope-intercept form, we get 3/4 x plus 15/4. Parallel lines. Perpendicular lines intersect at 90 degrees, and when you multiply their slopes together, give you -1. We also say that the slopes are negative reciprocals of each other. Actually, write that down. Okay, so here's how we apply that. Find the slope of a line perpendicular to a line with a slope of 3/4. So the slope would be the reciprocal, and we change the sign. So we flip and change the sign. All right, same problem. Same point, same equation, and now we're perpendicular. So we go -4 equals -3x plus 12. We're going to minus 3x from both sides, divide by -4, and get 3/4 x minus 3. So the perpendicular line would be the negative reciprocal, so we're going to switch the 3 and the 4 to get 4/3, and we're going to make it negative. So the slope goes here, and this point goes in there. So y minus 3 equals -4/3 times x minus -1. Simplify, and that's the equation of the line perpendicular to here that passes through -1, 3. That's the end.